Welcome to this Process Insights guided wave video describing the OmniView for 508 software. In this video, we're going to discuss the zero screen. To get there, click on the zero scan icon. This screen shows the current zero scan being used by the analyzer. What do we mean by zero scan? Zero scan is a measure of the light that passes through the entire path of the instrument, from the light source in the analyzer, out through the fiber, through the probe, and then back through a fiber back to the instrument. It's important to note that the zero scan must always be taken with no process material in the probe or the flow cell, whatever you have. The zero scan is used in the calculation of the absorbance. It's important to take good zero scans. It's also important to do them periodically as the state of the analyzer changes over time. Right now in the chart you see two scans. The current zero scan is being shown in green and the benchmark zero scan is shown in blue. The benchmark is simply a zero scan taken in the past against which we want to compare new zero scans. Gives you an indication of how things have changed in the instrument from some time in the past. To use the screen, first thing you need to do is to go to the probe or the flow cell and remove it from the process, clean it, and dry it, and leave it empty so that we can take a zero scan. So it requires access to the probe. So once you have done that, once you've prepared the probe for a zero scan, you click the Collect Zero Candidate. This causes the analyzer to take a scan and then display it on this screen, which you see in red. Now, there are actually three scans here. It's very difficult to see the current zero scan because the new candidate, in this case, and the current zero scan are very close to one another. Let's see if we can see a difference. Yeah, there we go. If you zoom in, you can see that, they're slightly different. Down here, we show the result of the validation process of the candidate scan. So what we do is we take the candidate scan that you just took and we compute the magnitude of the scan, which is the area under the curve. And we also compute the shape, which is computed from a dot product of the values in the scan. Those both give you a measure of the scan. And we have tolerances on those two values, which we set in the setup screen. Let's go briefly take a look at that right here, the zero validation tolerances. So the user can change those depending on how tight they want the limits on the differences of candidate scans from previous zero scans. So we see that right now we're comparing the candidate scan against the benchmark, the blue scan. And we see that there's quite a bit of difference. In this case, I think the shape is okay. See how all the little peaks seem to coincide between the two different scans. But what is different is the magnitude under the curve. The new candidate scan shows quite a bit more light levels. These are light level scans. And we can see that in this portion of the spectrum, we're getting more light now than we had in the past when we took this benchmark scan. Let's click this button, which then will compare the candidate versus the current scan, what I was showing you earlier. Current scan in green, the candidate in red. And we see that they are very close. By comparing against the current zero scan, we see that it passes. So there's two things we can do here. If you're satisfied with candidate zero scan, you can click this button to accept it as the new current scan. So we'll do that. The red scan became the green scan. The old green scan we've discarded now. Now we have a new zero. But there's one more thing we can do. Because our benchmark does appear to be rather out of date, things have changed in the analyzer since this benchmark was taken. The other thing we can do is promote the current zero scan, the one being shown in green, and make it the new benchmark. To do that, we click this button. So now the current zero scan and the benchmark are the same scan. Okay, so now what I want to do is show you what happens if you take a zero scan, say for example, while forgetting to remove the probe from the process. I have put the process back into the light path, and I'm going to collect a zero scan. Now this is going to produce what you would say is a bad zero scan. You can see from these light levels that there's absorbance going on down where the light levels dip dramatically. Those are areas where those frequencies of light are being absorbed by process material in the path. So this would not make a good zero scan. You can see that it clearly fails. Let's go back to the benchmark here. It fails against the benchmark. And is an indication that you've done something wrong. When this happens, you can click this button, Clear Candidate, to discard that scan. We've thrown that scan away because it was improperly taken. So now I'm going to go remove the process from the scan again. And just to show that that's true, I will collect another candidate scan, and there you see that the candidate and the current and benchmark scans all lie very close to each other. Now again, so since this latest candidate scan isn't very different, I'm just going to throw it away as well. This has been a demonstration of how to use the zero screen in OmniView for 508. Thanks for watching.